All right. Yeah, my hands are covered in splinters, so yeah, I'm going to struggle holding this. We had a reminder a couple of days ago about where we fit in New Zealand. We do regard ourselves as the most mission-critical business in New Zealand, and there's a number of things we do to support that, because it's in our blood, what we do, in terms of keeping the lights on. So basically, who are we? Who's Transpower? So basically, we obviously support and run and manage the grid, the national grid for New Zealand. That spans right up and down the country. We don't generate electricity, and nor do we sort of distribute it to your house or your business. That's done by local distributors like Meridian, etc. However, so Meridian and Contact and all those guys, they plug into us, and then we send the electricity up and down the length and breadth of the country, and then it gets sent out again 9 times out of 10 to the same guys, and then they send it onwards. So yeah, we're the spine of the country in terms of electricity. A lot of our grid, much of the grid is run from these centres. I'll quickly skim over this. We've also got a network operations centre, which is where we run our network, which I'll talk about in a minute. That's in Hamilton. We try to run the North Island and the South Island quite independent of each other. During a major grid event, you want to be able to control each island independently. And we can swap between locations, and we do on a monthly basis. Demand, as you can see, Auckland is a big demand centre for electricity. Wellington is a large one as well as Christchurch, and then you've got Tiwai down in Invercargill, and they plug directly into the grid, and a number of large paper pulp processing companies also plug directly into the grid. In terms of generation, you'll see down in the South Island there, a lot of electricity comes from Benmore, Clyde Dam, Manapori, etc. And then you've got areas up in the North Island like Huntly, and there's a lot of wind energy, etc. So basically what we've done is, and this is very common for a national grid to do this, we've built a large fibre network. We call it internally Transgo, and essentially we've run about 6,000 k's worth of fibre and other associated network pieces around the country, and of course included in that we have 5 Cook straight fibre cables on top of our 4 or 5 power cables that we run for the country. The big dog leg cable out the left there, that's a telecom cable that we're not actively using at the moment, but we will be in the future. Telecom use our cables as backup or resilience as well. And we also use a lot of fibre, radio, microwave, etc. to around about 220 comm sites. The reasons, I'll explain why in a couple of slides why we did this. It's carrier grade, so we run this all internally in-house. We, right from the ground up, we generate the light across the cable right up to the top. So very little of it is run out of house. So as a consequence, we're unofficially the 3rd largest telecommunications network in New Zealand now. We do this for a number of reasons, as I'll explain in a second, but it's mainly to carry SCADA, protection and equipment signalling, and of course corporate and critical systems traffic. And we've got a dedicated network operations centre, as I said before. That there is the laying of one of our cables across the Cook Strait by a boat that we've got some shares in. There's about 7 of those boats that float around the world. This one's owned by Alcatel-Lucent. It's called the Ile de Seine. Those boats can roll out 10,000 k's worth of cable in one trip without having to come to shore. So they're absolutely massive. That one there is repairing or relaying a cable that was broke or pulled up by a fishing trawler a couple of years ago. So that was a reasonably expensive repair bill. That's an ROV that we send down on a regular basis to check the health of those cables. So we're doing some pretty cool stuff in robots, which I'll explain more in a second. And we also have a number of boats, ex-Navy vessels, that patrol what we call the CPZ, the Cable Protected Zone, all day, every day, 24/7. So they patrol that. You're not allowed to fish or anchor or anything in there. And we've checked that the propeller off the inter-islands and it's not sitting on any of our cables, so we double check that. So our own fibre allows us to do a number of things, and this, as I said before, is very common for grids to do this. We ran fibre to protect and manage the grid, so we don't want to be in a situation where we have to share that infrastructure or share that data communications feeds with other companies due to, we don't want to be involved in hack attempts or loss of service or quality of supply issues. So that's why we need exclusive access to that cabling infrastructure to run the grid. And there's also the security information and, that we protect around the signalling. Corporate traffic is also fast, so yeah, we do a lot of things with high-def video conferencing, IP voice, Wi-Fi, etc., including at our branches, our sites, and we're also doing Wi-Fi into some of the substations. The fibre network, because of its size and its stretch, allows us to do a number of different things that we're exploring now. A couple of which are what we're doing in the world of robotics. So on the left there you'll see what we call our drone. So essentially that's quite a large remotely operated helicopter which you can operate from a branch office if you had to. It's equipped with all the necessary sensors and cameras and things like heat sensing and that sort of thing. We spend millions a year on helicopters flying up and down the length of the grid for inspections and that sort of thing. So by having a drone, it's a lot more cost efficient to have that sort of thing. So that's an area that we're exploring. That thing there can travel a distance of around about 200 kilometres, so without having to come back. And then on the right there, you'll see another robot that we're working with at the moment, which we've had designed by Massey University students, and that's what we call Substation Robot. And that essentially, the plan for that is that would be parked in a garage at one of the very remote substations, which we have a lot of. And in the event of an emergency or an issue or something like that, that can drive out of its little garage. And we use, believe it or not, an Xbox controller. And you can sit at a laptop in an office and control that. And that would go out and basically look and see. And then the reason for that is, you know, it can take 2, 3, 4 hours for someone to actually get to a substation in the event of an event. So this can get there instantly if it's at the right substation. So this is an area that we're actively looking in. One photo I haven't got up there is another robot. It's a bit like an orangutan. It sort of drives along the lines and it will swing and hang around lines and can inspect the lines by touch and feel. These two guys here, this one's a photo of mobile substations. So these are two very large trucks. One is 86 tonnes, the other is 36 tonnes. Both are equipped with 3G, fibre and satellite. So essentially, if we need to take a substation offline or for maintenance or it has a failure or whatever, we drive this thing on site, we plug it in via 3G, fibre and satellite, fibre being our Transgo, and then we can power whatever's plugged into that substation. Very, very large trucks. So a hell of a lot of work has gone into the communications technology behind those two units. That's another picture of one, just look at my guys walking around it, and that's a panoramic shot on my Gen I supplied iPhone. So yes, that's quite a large unit, and they're just about ready to go out the door now. And that's us. Thank you.